Welcome to this episode of the AEC Engineering and Technology Podcast, a podcast dedicated to helping engineering professionals find technology that fits their needs. In this episode, we'll be diving into the world of digital inspection and non-destructive testing, also known as NDT, with Hamed, co-founder and structural engineer at FPrimeC Solutions Inc., which specializes in advanced non-destructive testing and evaluation of concrete materials and structures. We'll be discussing the applications of digital inspection, the latest innovative NDT methods for evaluating concrete structures, and how NDT can be implemented in new construction projects. We'll also be exploring how NDT can be used as an integral part of structural condition assessment to identify and prevent potential structural failures. So whether you're new to the world of NDT or a seasoned professional, you won't want to miss this episode. With that, let's jump into today's episode. Med, welcome to the show.
Thank you. Thank you very much, Nick, for having me in this show.
Absolutely. Great to have you on and thank you for the time. But, just as a kind of a quick introduction here to the audience, could you tell the listeners a little bit more about yourself and what you're doing on a day-to-day basis?
Yeah, thanks again. And it's a pleasure being here. My name is Hamed Layssi, and I'm a co-founder at FPrimeC Solutions. We are a technology company, and we are very much involved with inspection and testing of concrete infrastructure.
Excellent. And, right, Ahmed, we're in very closely related fields here, right? So I'm excited to start talking about really just the overarching topic of digital inspection and NDT. So let's kick it off. How has digital inspection basically changed the field of NDT or non-destructive testing, right? Because I imagine the point it's at now has probably progressed pretty significantly in the past few years.
Yeah, I came across the notion of digital inspection a few years ago when drones started coming in, and people were getting more excited about documenting things with the help of technology. And since then, we have seen a rise in various technologies based on AI, computer vision, changing the landscape of inspection. But personally, in our practice, I would say early 2022, it was around the time that we really tried to do some of the stuff that we used to do, old-fashioned, taking pen and paper to the field, and try to change that a little bit in order to optimize the workflow, reduce the inspection timelines, reduce the reporting timelines. And that's about the time that we really tried to bring digital inspection in real practice.
Which is, and I agree, right? And it's you said early 2002, right? It is amazing kind of how much has just kind of come onto the market, right? Became available to the industry in the past year.
Yes, yes. I would say one of the problems that I there are lots of cool technologies out there. Most of these technologies are still in the process of development. They are becoming better and better every month, I would say. But as a small company who tries to serve a large market, especially a very serious market, let's say mining inspection, you always need to have robust tools that are capable of taking care of your A to Z process in one single platform. Unfortunately, not most of these platforms are still there. So what we are trying to do is try to split the tasks and bring the technologies for each task and try to digitize that particular section, and then kind of stitch everything together, still manually, but hopefully in the future, everything will be done in a digital space for sure.
Yeah, and kind of segueing into the NDT portion of this, right? So for a very long time, right, you would have your visual observations, right, and then your non-destructive testing data, and they weren't always coupled, which I know has been changing, pretty recently. But could you talk about some of the more innovative NDT methods in concrete inspection and explain how they work?
Yeah, that's a very good question, and I think I I really want to say like we really start at NDT, not inspection. And most of the people like ask me about like digital inspection, but like to be honest, like we started at non-destructive testing. But then soon we realized like the foundation for a good non-destructive evaluation is a good inspection. Like without inspection, like you end up like putting too much cost into your like condition assessment, and the customer has to pay for it. And at the end, you are not going to get the result that you wanted. Now, the nice thing about FPrimeC is like we are really working at the intersection of digital inspection and non-destructive testing, and how we can bring some of these tests that traditionally used to be done like separately, and then the engineer had to take care of this, like bring all of these pieces of information into their report, and then the engineer as the mastermind has to stitch this information together and try to come up with an engineering report. Now, this is good, but certainly can be improved. Now we have like platforms that are capable of like uh, automatically importing the data into your like workspace. So reducing the amount of like the time that needs to stitch this information together. And more importantly is like the tracking based on location. So most of the time, you look at the inspection report, you have to do this non-destructive testing in the field based on the inspection report. But too much information to read, too much information to compile, and you go to the field. There is always like limited time that you have with the structure, and then you come back to the office and you say, "Wow, we missed this one, we missed the other like GPR in this particular location." And you end up like with a report that is not 100% complete on every aspect. So digital inspection now helps you have a very good workflow. So you know what tasks needs to be done. You have the location in front of you. You know how you are moving across the plan, and you can put directly the test results into that particular location. So you have the geolocation for the information you collected with the NDT. So uh, the mistakes that normally happens with the engineer with the fatigue in the field and you missing information or like mislocating the test areas is like less likely to happen when you are using a digital inspection workflow.
Absolutely. And isn't it crazy, Hamed, how, right, like just something as simple as, right, like let's just say we're in a parking garage, right, and you want to identify a problem with like a connection between two precast pieces, right? It sounds
Exactly.
kind of crazy, but up to this point, right, that wasn't always the simplest thing to do. But now the inspection methods are just getting so much better.
Yeah, I would say as much as I would have liked to see like NDT grow, I haven't seen too much fundamental like change in the world of like non-destructive testing for concrete. But inspection is different. Like digital inspection is like going at a light speed. It's like changing the landscape. You and I have had like a couple of interesting discussions in the past, like how a simple 360 camera basically can save you days in field inspection. Like you go there, like you miss something, you always have a very good backup of information that will prevent you to redo that trip, that long trip to the job site, spending time finding the location, getting the record. So if you miss something, if you have like by any chance missed to record something, you just have a very solid backup of information to use.
Yeah, and rolling off that topic, could you talk a little bit about the difference between NDT and just traditional inspection, whether digital or not?
So I think there is a very good analogy between structure inspection and like a medical examination, diagnostic test that we have for a human body. Like you go to your family doctor gets the symptoms, then based on the symptoms, you get like blood work, you get like some imaging. Now, in the imaging is kind of the NDT part, okay? And the screening question is like your inspection checklist. You go like, you tick like there is crack here, there is sign of corrosion here, there is moisture here. So those signs basically navigates the engineer it navigates it, like helps the doctor select the best diagnostic imaging or testing protocol for you. For example, somebody might just need an X-ray. The other, the tumor might require an MRI with injection, for example. Now, the same thing happens with the structure inspection. So based on the inspection results, like here is corroded, here is cracking, the engineer comes with a series of tests, diagnostic tests, and that is the duty of the NDT practitioner, like the NDT technician or the NDT engineer, based on those results of inspection, comes up with a plan of testing. So with the testing, the gap you are trying to address is basically collect more specific information about particular location. In general, normally it's going to be very expensive if you want to do NDT on the entire structure. So you always need that roadmap, that inspection report to show you, okay, this particular element requires like half cell testing to see what's the state of corrosion. This particular slab requires like chain dragging to identify the extent of like delamination. So always like a visual inspection, I would say, paves the way for like doing a very good NDT. And NDT is the diagnostic test. It gives you the information that otherwise you won't be able to collect about the condition of the element.
And I love the analogy of our field back to medicine because it just makes it that so much more easily understandable. And in fact, right, and continuing on kind of that analogy, right, there are some things that may require the skill level of a licensed engineer, right? Perhaps that high level overall inspection, but there are others where, hey, that engineer's time may be better spent somewhere else. And there's a skilled technician, right? But they don't need to be licensed because what they're doing is, right, similar to like a medical technician. Very important, but not, but just kind of a different trade, so to speak.
I would say yes. I would say that's very correct. And unfortunately, and I know like some tests are like trying to bring these licensor programs like GPR. I know is on track for this. Other methods, I know ACI, for example, has like some certification programs for more old-fashioned like testing, like quality control tests. They are very well standard. Like you really have to go and get your licenses for those type of like testing. NDT is, I think, people are still juggling, and we haven't come up with a standardized way of making sure all the inspectors know what they are doing, how they are doing things, how things should do. Like most of the tests that we use, they already have an ASTM like standard, but engineering community still has not really decided if this is something that can independently be done by inspectors or not. And I think this is a topic that over the next decade, we will have to really work hard on this and come up with some sort of standardization as the medical industry has come up. Definitely, it's not going to be more difficult than interpreting or doing an MRI or an X-ray. So I think that is the way to go forward. Like we need those programs to be able to break down the costs and try to inspect more structures instead of keeping it very focused on an engineering corporation that never scales in a global scale. We really have aging infrastructure. We have to come up with programs that can facilitate the process of doing this inspection more effectively.
Yeah, and the engineer acts like that, right? In some cases, that general practitioner, right? In other cases, like a surgeon, but they're ultimately responsible for the care of the human, in this case being the structure, but they can still delegate successfully. So I agree. I think it's going to be a very interesting topic of conversation, but Yeah, infrastructure is not getting any younger, and they're not making engineers right as fast as maybe they once did. So there's definitely a need to fill. But transitioning from existing structures and inspection, let's talk a little about new construction. This is admittedly an area where I'm not as familiar, but I know NDT can be used in applications in new construction. Could you talk a little bit about that?
Yeah, that's also a very good question, because some people think that NDT is only for existing and structures that are already experiencing a lot of damage. But my idea is kind of different. I think NDT has the capability and potential to be implemented right from day one. And in that aspect, I would say digital inspection is also an important element from day one. For example, you see beam modeling, it's booming these days. Everybody wants to have a beam model for their assets, and this is going to be very helpful. Most of the problems that right now we are trying to help our customers with is the assets that we don't have any information about. Most of the NDTs that we do on existing buildings is because of the lack of information about them. Not a very good documentation, no very good drawing records or archives available. So the engineer has to fill those gaps with lots of testing. So makes it more expensive. Making a digital inventory from day one, on the other hand, basically gives a very good archive for future generations. When they come back here, they know what was involved in the design, how this was done, in terms of quality. For example, the general simple quality control process these days for concrete is a slump test, air test, concrete cylinder, compressive strength test. Now, lots of problems occur during the construction that never really gets into any of those reports. Okay, so there is the honeycombing area that a company came and did the inspection, and the inspection report is somehow lost over the process of transferring the assets to the owner, and then from the owner to the next owner. So 30 years from now, if you don't have those information, you don't really know if this foundation was built properly or not. So I think in that regard, NDT with digital inspection can combine and bring more clarity and more useful set of information for early construction. I want to give you a quick example if we have time. I am called into, for example, sometimes contractors, very good contractors, doing a massive and a very interesting job in a mining project, for example. Problems happen. One day your pump doesn't work, one day it's extraordinarily cold, and you want to make sure the construction process moves according to your schedule. And things can go wrong. You have a poor quality concrete forecast, and now you have to come up with a fix. Now, traditional testing is just take your drilling machine, take core from every 1 meter, collect 20 samples, and say if the structure is good or not, and if it passes the quality or it has to be rejected. Now, I think NDT is really capable with the advances that we have seen over the last decade. I think it is at a state that can be implemented in the QC or QA process. You can take NDT, for example, ultrasonic pulse. You can combine it with other methods. You can come up with a customized setup and talk about the quality and integrity of an asset in day one. And that has the advantage of being minimally intrusive. You don't need to take as many cores as otherwise codes and documents need. And that is part that we as engineers have to work on and try to allow more NDT testing in the QC QA process.
Which is really intuitive, right? Because if you can get away with causing as little damage to a structure as possible, right? That it just makes sense, because that's less to repair, right? It's less in testing costs, et cetera. But it's again an interesting point of conversation, and how the discussions in the engineering community change, how the codes ultimately change, and kind of how it all gets brought together to, like you said, build basically a history for an asset from day one.
Yeah, absolutely. And I think like there are like NDT solutions that are more capable of like just simply taking a core sample, because with a core sample you may get like compressive strength right, but there are so many other things that you will miss because the core has a limited size from a particular location, whereas in NDT you can cover more of the area, more of the surface. Like you can test the area adjacent to the problematic zone, see if the problem is more widespread or is just localized. And these are like piece of information that gives the design engineer at that particular stage of like a construction the confidence to move on, to make a decision on accepting or rejecting the structure. And the example I gave you is just one out of many projects that I have been called to comment on the quality and integrity of concrete. We have had like girders, brand new girders that had been like damaged by accident during construction. We have had girders that had been exposed to fire, like a concrete element, like for example, one of the in Canada, which is like a cold country, in what happens for concrete construction in the winter is like cold joints. Cold joints can simply become a major problem. Now, what do you want to do? You want to take like cores every 1 meter across the joint just to make sure like the joint is like an integrity issue or not. So in those cases, I think NDT is definitely the future.
So regardless of the situation, or whether it's new construction or an inspection in an existing asset, right? There's got to be some kind of core principles to NDT that can be applied pretty much universally. Could you talk about some of those?
That is like that's a tricky question to answer, to be honest. Like as like standardization, I think like we still like those like standard like process of becoming an NDT inspector engineer. But that being said, I think many manufacturers and many training institutes are out there these days to help you get hands-on experience with some of these technologies. For let's say GPR, like you don't really need any permit from anybody to do a concrete scanning. It's like as long as you can deliver with confidence, I think you're pretty much good to go. Now that is the good thing about it, which gives like which makes it a interesting tool for a broader like part of the market. But at the other hand, we also have to come up with a mechanism to de-risking using some of these technologies. Like I have seen like in the industry, people who claim to do all the stuff with GPR. And I think like that is what makes the engineering committee, myself involved, concerned about the practice. So if I am in the process of delegating the task from an engineer to an inspector, I have to come up with a mechanism to ensure the quality and integrity of those test results, because nobody wants to go in an X-ray machine and comes out and being said that, yeah, you have to do the test again. Okay, so you are paying that, you are investing the time, you are investing the the capital and all the anxiety and the time that everything is pending the test results needs to be repeated, and nobody wants to be there. So coming up with a process to ensuring that inspectors know what they are doing and how they are doing it is essential. And I think in that regard, the engineering community has some work to do.
And again, it's just that continuing education, adoption of standards, right? And then, as you said, that setting those kind of specifications, because if we're only human, you can't do everything. So as right, testing gets delegated and that becomes more commonplace, having that standard set is going to be critical.
Definitely.
So now, and we can shift back here, and it's not really a case of existing versus new, because this can happen in either, right? But structural failures, and they've been in the news a lot lately. I think the biggest one here, stateside at least, was the Surfside Tower collapse. I believe that was in 2021. Right. I know
Right.
we started getting calls from concerned asset owners just in a wide range of different asset types. But I am curious, how does NDT help mitigate potential structural failures?
This is also a very interesting question, and I think the answer is like NDT cannot help in how people are expecting it to do. It is the engineering use of NDT that basically helps you solve that problem. So for any particular asset, let's say like you have a building, you have like a settling basin, you have like a bridge, you have to come up with a standardized like a protocol for inspection and for testing. So for example, for bridges, we standardize the bridge inspection pretty much nicely. So every inspector knows what to do, what information they have to collect, and how those information can be translated into like maintenance needs for the asset owner. With NDT, we don't have those type of standardizations yet. So every structure is different, but NDT can come into play as part of your maintenance program. So for example, if you have let's say parking garage, you don't want to do like MRI every year. Okay, so the same thing happens with the half cell corrosion potential testing. You don't need to do half cell corrosion potential testing every year unless you really are experiencing some corrosion and you are in the management phase. Okay, defect management phase. So for a brand new structure, you might just want to have an eye on this every 5 years. Let's do and see if the structure is like doing well. Okay, now that becomes like your blood work. You do the blood work every year, and then if there is something like not good, they send you for more tests. And now in this aspect, I think NDT can be very, very useful. So it provides an extra layer of information, not just visual, because some of the defects you don't see it visually. Like corrosion, it takes a while for corrosion to be seen on the surface. So by the time you see the corrosion on the surface of concrete, it has already progressed too far. So you want to have like information in advance, so you can have better planning. And considering that cost of repair and replacement is always like more than like doing a proper inspection, I think it's good if like engineers can help asset owners bring NDT in their maintenance protocols, inspection and maintenance protocols. So you have the inspection, it has to be done every year. You may come up with an NDT program that comes every 3 years, every 5 years, depending on the nature of the structure, the type of defects that you expect on that particular structure. You can play with the periods that these testing have to be repeated. And I think in that case, the engineer will have a very good set of information that can progress the health and condition of an existing asset. Is it like deteriorating fast? Is it normal? Is it like we really need to intervene here, stop the corrosion right here, right now, in order to save this asset for another 50 years? And another aspect is like, and this is the case because most asset owners come to us when it is already too late. Okay, so you go there, like you see a parking garage that is already like crumbling down. Okay, what do you want to do? In this phase, NDT can help you come up with what I call management plan. So for example, if you go to a specialist, not every tumor needs to be like surgically removed at the very early stage. Sometimes they come up with a management program. So let's keep an eye on this. Let's repeat the test every 6 months and see if it is going like progressing as it is expected, or is it like getting like more dangerous and more critical stage. So this NDT, I think, can also help engineers come up with management programs. For example, there was a bridge here in Toronto, and we knew that the bridge will be decommissioned in like 3 years. But from now until 3 years, is this safe to be there? Can we keep it open to the public? Is there a risk of like pieces falling down on the highway? So these are things that I think like well-designed NDT protocol can really help you.
And the overarching theme here I'm hearing, Hamed, is it's not the technology that stands alone, but it's the human, or in this case, the engineer's use and interpretation of it that's really important. Because if you aren't using the right tool for the job, you run the risk of things not going as well as they can.
Exactly, and that is, I think, that is where I say like every asset owner requires a consultant working with them closely, overseeing their maintenance programs. This is pretty standard when you go to oil and energy, when you go to mining. These inspections are done on a regular basis. Concrete structures are often overlooked, so they don't really get the attention they need. But the entire, like the overall process is out there, okay? It's just like engineers have to articulate these concepts, this like maintenance for concrete properly to their customers, so they have a better understanding of like the maintenance needs that they are going to expect in the next like 5, 10, 15, 25 years. Speaking of which, you will need, for example, this test every 5 years. This particular test is cheap, you can do it every year. And then the information, basically, if you give it to owner, they don't know how to use those. So the art of engineer here is to come up with a conclusion based on those information about the strategies that can help the owner like protect their assets properly in a cost-effective framework. Because like you can test everything every year, and the customer will like just go broke very soon. But if you come up with a nice intervals, you will get the information that you need, and also you can help them like plan in advance.
And a big part of that too is just making the data more easily understood. I like to call it, recognizable reality, right? Because there's a difference between, and I'm just speaking at a high level here, like waveforms in from GPR versus, let's say, like a heat map where it's very clear where the suspected problems are lying, right? It's roughly coming from the same data source. There's some interpretation between the two, of course, but one I would say is probably more easily understood by lay people and asset owners.
Absolutely. That's a very good point. And like when I started with Farid at FPrimeC, like now it is 8 years ago. The first idea that I had, and I brought it to the market, and I think was kind of a game changer, and I saw like many manufacturers adopted that, was data visualization. So before that, like you had like 4,000 meter per second UPV wave speed. Okay, so what does it mean for me? Okay, it's like giving you the X-ray like a film, and they say, okay, go home with this, and you will never know what's happening. So the art of the engineer here is like very similar to the art of the doctor that translates those like X-ray films to data that the patient can understand. So we have to do that. And then the second thing is like that I came up with like kind of recently, like after like visualization was done. Now I think they require like action plan. So any inspection and like testing that misses out on giving the customer an action plan is kind of immature. So it's not complete. It's like, in my opinion, it's a waste of time and money. But if you have an action plan, then the customer knows what to do. And we have had like the most successful experiences with clients that already had like well-developed maintenance plans, for example, in mining, steel manufacturing, and they could easily absorb what the information that we gave them because it had a timeline. Okay, so this part is like crumbling right now. You have to intervene immediately. If you don't, somebody might get hurt. So this is the information they want. If you give them like what is like the health potential value for that part, they start like keeping you. So that becomes the backbone of the information why you are prescribing this solution. That goes into appendix in my opinion. The key part is the executive summary that you put on, like, here in months 0 to 6 months you have to fix this, otherwise there is a chance that somebody gets hit. In 12 months you have to fix your concrete slab. In 5 years you have to like redo the coating on your exterior walls because of like A and B and C. So I think right now I am trying to come up with like ideas how we can actually transform data into action plans. So if we can kind of like automate that or standardize that, I think we will have a huge step towards like making it independent of like inspectors and engineers, like kind of standard like workflow. But I'm not going to say that like we want to remove any engineers or inspectors. I'm just going to say that you can do things more efficiently, time-wise and cost-wise, and then you can expand the work. So previously asset owners, like because inspection was a luxury, only few could afford, like they kept like this inspection to a very limited set of structural system to a very specific area. Now with the help of digital inspection and help of like all these cool things that is happening in the NDT and the domain, I think you can cover like way more areas in the same period of time. You have more information at a more cost-effective rate. So that is the key.
And we've talked about it before, right? We mentioned earlier 360 photography, where before, right, you were limited to standard 2D photos, right? You have to correlate them to a location. There's software you can just walk through 10 minutes, and end of the day, you have all of those photos mapped to pretty good locations per a plan, and it didn't take you any more time than your walk, and it's becoming very cost effective, right? So we're able to do more with the same. But and kind of speaking on that, right, innovation and just emerging technologies, what are you seeing in the NDT space that you're excited about in, let's say, the next 3 to 5 years?
This is a complicated question to answer. Like having been in some of these conferences with regards to NDT, I think as we are seeing more advances in the like computer vision, AI, we are going to see a set of products that can provide information in a more processed way. So right now, most of these devices out there are giving you the raw data, and the engineer has to work on the data and process them and come up with something meaningful. But I think what artificial intelligence is doing is basically shortening the process of like going from raw data to kind of visualization process, making it easier and faster. One of the questions, for example, I'm always asked, literally always, that I go to the job site, they ask me, can you tell me how is it doing? And the answer is no, we have to take this data back into office and do the processing. Now, for example, the advantage of GPR is that you can set like most of those information right on the spot. And that is why it's becoming more and more popular. Now you can see the same trend with other technologies. So like, for example, ultrasonic techniques, they are becoming easier to work with. Traditionally, they were more difficult to work with. Like you really needed like to take courses and training courses to be able to interpret them. Nowadays, like the devices are coming with inbuilt solutions that is helping them. In a grander scheme, though, like I think there are like some fundamental like research in ultrasonic, nonlinear ultrasonic, laser scanning out there that is definitely going to change the landscape of testing in the future. But until then, like we have to stick with what we have right now. And I think there are like two elements. One is the innovation in like the physics of the testing. That is more university job, like professors and PhD students are working to bring like new technologies, new concepts of testing. The other step is on engineers to come up with innovative like processes of using existing technology in their practices. And that is where I think I see myself and as an ambassador of like this practice. If you don't practice this, this field is never going to develop or improve. But I am very happy to see more engineers are basically moving toward digital inspection. They are moving towards like the non-destructive testing and evaluation. And the more demand it is from the market for this, we will see more serious fundamental change in the science behind the technologies. Manufacturers will be pushed to go and bring better solutions. They have to go back and bring more innovative ways of like visualization, workflows. And I think like over the past 2-3 years, I have seen some companies like being very, very good at doing this and helping customers with what solutions that they have brought to the market.
And it's the same way we as the engineer or, you know, the equivalent doctor, right, explain to our client, simplifying the data that we collected and the analysis that we did to provide an end result that's easily understandable. And you're right. The role of a lot of these software companies is to say, you have problem X as the engineer. I am going to not take it off your hands completely, but provide you an avenue that you can understand and is easy enough to do to provide the desired end result. So crack mapping, right? Great example. Exactly. Very, very tedious, but there are a lot of emerging technologies that can start to tackle something like this. Now, that doesn't take anything away from you as the engineer from an analysis standpoint, but if you don't have to be out, you know, literally drawing cracks or mapping cracks yourself, and like AI or software can help you with that, right? It's just the promise that something like that brings is just amazing.
I think like that's a very good point, because like if you don't push yourself, yeah, like you will just repeat like what has been like traditionally done over years and years without like truly helping customers. Okay, so I see the gap there. Like engineers have to be innovative. Engineers have to come up out of their comfort zone of like codes and like practices. They have to push codes forward. And pushing codes and like guidelines forward is only possible if you bring it into engineering practice. If you publish your failure stories, if you publish your success stories, if you bring up the problems that you have with particular practices. Why I am saying that corrosion cannot be detected with GPR, for example. Okay, and now why I claim that corrosion can be detected with GPR. It's kind of like a scientific process. Like you have to come up like and in arguing with each other, we will help the entire practice move forward. And that is what engineers really need to do. Instead of like keeping inspection and inspection business and like don't get involved with inspectors, I don't think that's the way to go. I think engineering is an integral part of any asset management. You cannot take engineers out of this practice the same way that AI and computer vision is not going to remove the surgeon or like the radiologist soon enough. So I think we are very much going over the next 10-20 years. We will still be very much dependent on these specialists to help us better understand, until like we see the next leap in the technology coming up with other like innovative solutions, perhaps in the next 20-50 years, that can help us like see more clearly, more accurately. But until then, we really have to keep that engineering element, that knowledge element. I would say it's not engineer, it is the knowledge. It has to be knowledge based. So as long as like you know what you are doing, it doesn't matter if you are certified or not certified. That becomes a legal issue. So I put the legal side aside. Uh, as long as you know what you are doing, you're pretty much good to go. And knowing what to do is like means you have read all the literature available, you are competent, you are continuously reading and updating yourself with the practice. You take courses, you take like online courses, you participate in like certification programs, and that is it. That is the way to go forward.
And you bring up a great point that we talk about all the time on the show, right? Like, is technology going to replace? In many cases, the question is engineer, but it could be architect, it could be design professional, right? In this case, right, like you said, throw away the titles. Let's talk about the knowledgeable individuals. And frankly, I mean, I don't think so, because you're an asset owner, right? You only know so much about the kind of the asset that you own. Do you want to be leaning on a computer to guide you, or do you want kind of the advice and the guiding hand of a human? I don't see that changing anytime soon. I think you're just going against human nature. So by that alone, there's going to be a role for humans. How that role will change is going to be very interesting. So we're gonna have to stay tuned to that. But I mean, I just wanted to kind of wrap up here and ask. We've talked about, right, NDT here and kind of how qualifications have been changing, right? Like who can do it, who's knowledgeable, but what are you like? Somebody asked like, hey, I want to make sure the NDT professional I engage with is knowledgeable, professional, and knows what they're doing. What should they be looking for in that individual or company?
This is like this is really, really tricky question to answer. Lots of politics, I guess, goes into this, but I think like for every particular like technology or testing method that is out there, you have to know the principles. So if I am the structural engineer in this company and I have like inspectors working under my supervision, I have to make sure like they are already up to date with the existing code of practice for that particular test. If it has an ASTM test, they have to have studied this ASTM standard like properly. They have to know the steps that it takes to perform that particular test, and then the limitations in the field and in theory. Okay, so because like there are some restrictions for each of these technologies that are out there. Some of them comes from the physics, some of them comes from the job site. So sometimes you go there, like the technology, you know, the concept works. You go to the job site, you see like there is a tile or like ceramic on the surface of the concrete. Okay, so everything changes. So this your internal like educational system in your company should be capable of like teaching and transferring this set of knowledge to the inspectors that they have until like we get a like course that is kind of standardized across the market. Everybody accepts that standard course and allows people to work with it. But out of this, I have found like GPR to be very easy in teaching and transferring knowledge. Ultrasonic test methods are like more difficult to educate, mainly because the physics behind the technology is more complicated. You have to have familiarity with the like frequencies, speeds, energy, the concept of energy, and how different like geometries could affect like the signals that you are collecting. How like electrochemical methods the same. Like one thing that we have to make sure, like as engineers, that is going to happen is that like all these tests are like a computer software. If you set garbage in, it's going to be garbage out. Okay, so if you don't know what you are doing, like if this is like a ceramic tile and I do half fill corrosion, yes, I am doing it like according to ASTM standards. Okay, everything is right, but I'm doing it on a wrong setting. So I think what happens is not just educate people on how to do the test, but also educate why we are doing this test. Why I am saying this should be tested with ultrasonic and not GPR. or the reverse. Why I'm saying that Clay-Bond hammer is not going to give you the answer that you wanted in this particular case. So these are like things that traditionally, I think engineering schools tried to teach students, but I think they failed. We don't see a very good like educational like course that brings the students ready to work. We don't have that problem in NDT of metals, but we do have that problem in NDT of concrete. And I think engineering schools, like civil engineering schools, have a duty to bring more NDT in their like official curriculum, so that the engineers, when they come out of schools, they have a very good understanding of these tests, why these tests are done, how these tests are done. And then like engineering associations and standardization like groups, they can work together and come up with some standardization programs. I think like GPR community is kind of like forward thinking in this aspect. I think other other tests should follow the same.
And again, and if the audience leaves with, just a few like kind of key components to this, it's right. You need to understand what you're doing, no matter what it is, right? It's structural analysis software, garbage in, garbage out, right? Your understanding of non-destructive testing methods, garbage in, garbage out. And I think that's where the experienced and knowledgeable practitioner just isn't going away anytime soon, because in this wild west of technology, as I like to call it, you have to be able to sort through like, well, is this the appropriate application? Is this, a realistic use case for what you're trying to use and discern? And you just need knowledgeable people, because I don't really see any other way to accomplish that.
Yeah, I think the best thing for this is like to establish communities, like NDT communities. And on my part, I tried, and I would say to some extent I succeeded, but not as much as I had expected to. But it is with the dialogue and with the conversation between us who are practicing this that things will evolve and move forward. Otherwise, some of us might be doing it right and we will keep doing it right forever, and some others are like going to do it wrong and they will do it wrong forever. But I think as the moment we start like talking about it, and one of the things that we talked about like in the past is that like why I'm sharing all these stories every day. The only thing is like it's the best learning method for myself. If I am doing something wrong, I would like to know it like right here, right now. I don't want to keep doing the wrong thing for ever and ever and ever again. It's the liability issue. So I want to know the first-hand information, the most up-to-date information. And there are out there engineers like yourself and many others that are like helping me better understand what I'm doing, why I'm doing it, how I'm doing it. And this is kind of shortening the learning curve. Instead of like traditionally you had to go to school, like do 4 years of schooling and then like a couple of years of working with other members to learn how to do. Now we are in the global age, like everybody is trying to help you put one piece of this puzzle together and making it like happen much faster and more effectively.
Beautifully said. And that's one of the reasons, right, that we at AMI started this podcast, just to be able to get the word out and just give, it in the most part, engineers, right, but also architects and other practicing professionals in AEC an avenue to build that community and be able to find the info that they need. But Hamed, it has been a pleasure getting to talk to you on these topics today. But if our listeners want to connect with you and find out a little bit more about what you're doing, what's the best way for them to find you?
Yeah, so like the best way like is LinkedIn. I say I'm a pretty loud voice in LinkedIn, and I am pretty much available in LinkedIn. So I would say that is the first line of access. But then FPrimeC.com, the website, always a great portal for educating yourself on the most advances in inspection and non-destructive testing, and also a gateway to getting to connect with me or my business partner, Dr. Farid Morad. Who is a more like is a far better professional when it comes to non-destructive testing in terms of like scientific backbone. So both of us are open to discussing anything that you might be interested in.
Yeah, absolutely. And, and we appreciate that offer, Hamed, because at EMI, right, we say the same thing. We are just here to help. So please reach out to Hamed, reach out to myself, and we'll try to answer whatever questions we can and provide you with what we can. But Hamed, again, thank you so much for joining us.
Oh, thank you very much, Nick, and your team. It's a wonderful thing, and it has been a pleasure being with you again. Thanks.
Absolutely. We will catch you next time.
Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during the episode. Until next time, I wish you all the best in all of your engineering and technology endeavors. Thank you.